All right, everyone, welcome to our week 10 live classroom. For those of you who are here in person, glad you guys could make it. So real quick, I wanted to share something with you guys that I did this morning. I got a request from a student to see the slides from last week, and I was like, you know what, that would actually be really helpful to provide the slides for you guys. So while they're not built to be used without me presenting them, I have provided them for you guys in our video spreadsheet. Just in this, I added another spreadsheet tab here where I've put the slides for each of our live classrooms. Okay, those aren't locked or anything. If you guys want to look ahead at future weeks, you totally can. And so, yeah, just want to let you guys know that these are now available to you. So outside of that, any questions about last week, about the assignment, about the exam, about loops, anything? Okay, well, I'll take silence as you guys are good to go. So in that case, let's go ahead and dive into week 10. So chapter 9 is the chapter that we'll be covering in the course this week, and it is on functions. Okay, and before you guys get all worried, know that we've been using functions all along. Everything that you will see today should look pretty familiar to you. It was actually funny. So this morning, while I was putting the links together for the slides, I saw this one from week 3, and lots of questions at the beginning of the semester about Robbie the robot and why you couldn't put like a 3 into the move forward function to make the robot move forward X number of times. And so this is called a parameter, and today we will go into, as we go into functions, we'll learn about parameters and how we could make something like this work. Okay, so what is a function? Okay, it is a small piece of the program. It's a chunk of code. In many programming languages, it's more often called a method as opposed to a function, but they are basically the same thing. And functions can do a number of things. Welcome to whoever just joined. So let me blow this up a little bit. So this function right here has a function header. Every function will have a function header where you declare the function with the keyword name function right here. And you will see this in every single one of the programs that we've made up to this point. We always declare a function name with this keyword function. And then we have our opening parenthesis and our closing parenthesis, which up to this point we have not ever put anything into them. And then we have our opening curly bracket and our closing curly bracket or brace with the function contents. Okay, so inside these parentheses is where we can put our parameters. Okay, you can have one parameter or you can have 1,000 parameters. You can pass in strings, numbers, function names, objects, arrays. You can pass in anything you want. And these are where you will put your parameters. And when you declare a function and you have these parameters listed, you can basically use these as declared variables. And so instead of me declaring param1 right here inside the function, instead, wherever this function was called, a value was passed in to that first parameter. So this first space before this first comma. And so instead of me having to declare param1 in here, I can just use param1 and we'll have whatever value was passed in from where the function was called. Okay, and we're going to go through some examples of this, but do you guys have any questions about this concept? Okay, well then let's move.
Does that mean we can run functions inside functions?
Yes, there is. Yeah, so in a lot of programming languages where you have a method, you'll have like a primary method, which is frequently called main. And inside that primary method, there are lots of functions. But when you compile that code, it will look at that main function first, that main method, and it will run it, and then anything that's inside of it will also get run. And it's the same thing with just regular functions in JavaScript. I could have a function, I could have nested functions. We won't have any examples of that in this class. But one thing that's extremely common is to have a function with other function calls inside of it. So I might not always declare functions inside of functions, but very frequently I will call other functions from functions. And what that would look like, if I pulled this up right here, let's say I have a function called get circumference. okay? And I could have, can you guys see this okay? Let me blow this up a little bit. So as a parameter here, I could have like radius, okay? And then I could say return radius times 2 times pi. Pretty sure that's, you guys don't judge me if this is wrong, okay? But so this could be a function called get circumference that I could use. And let's say in whatever function I had down here, I wanted to actually get that circumference. I could say, you know, var circumference equals get circumference, and then I'd pass in a radius like that. Okay, so this is something very common where I call a function from within another function. But Spencer, to your question, it is possible to declare functions inside of functions, but it's not very common. Usually they're outside of each other so that they can be used by any place in your code. If I was to put this inside of this function, it still wouldn't get run until it was called, okay? But I couldn't use get circumference anywhere else outside of this function that it's inside of, okay? And for that purpose, usually we declare functions outside of other functions, okay?
So this is like function inception, like functionception.
Yes, yep, well said. Okay, so, but here's a simple example of how you can use functions. Okay, so this would be a very reusable function. Anytime I have a radius, I can be like, okay, let's call our function get circumference. I'd pass in a radius as a parameter, and then I can use that radius right here. I don't have to declare it or anything, but whatever the user passed in, I can use it, and then I will return the circumference. Okay, again, I'm hoping that this is the right algorithm to get this.
You have to raise radius to the second power. It's pi r squared.
Oh, pi r squared. Okay, thank you so much. So let's say math.pow radius squared times math.pi. Does that look better? Squaring radius,
Yeah.
math.pi. Okay, thank you. So anyways, and then when I do this, I'm returning a value, in this case, the circumference, and that return value will go back to this call point and be assigned to my variable circumference. Okay, and that's how you guys can use functions. And notice, like I said, we've been using functions all along in the class. We just haven't used multiple functions. We haven't used parameters. So let's go into this a little bit more. Any questions about this before I head back to the slides?
It looks like you ran the get circumference. Why'd you put a 5 in there at the very bottom?
5, I was just assuming that like that's the radius of the circle that I wanted to find the circumference of. So this 5, I could put anything. I could put like 88.6543, you know, but that's just a radius. So when we use this function called get circumference, we can pass in any number. Okay, in here we're just going to do some math. So it has to be a number. It doesn't have to be a whole number, or you know, it could be a decimal, but it does have to be a number so that we can do math with it. But I could pass in any number in here to find what the circumference of that radius would be.
So as you set as the variable circumference, the function get circumference.
Yep. So I didn't specify anywhere. I didn't say like var radius equals anything, but that gets this value as soon as we call that function. So if I didn't pass in anything, if I just had like opening, closing parentheses like we usually have in this class, radius would be undefined because we didn't give it anything. And this would give us a big old ugly error because it couldn't do math on an undefined value. And so with our get circumference function, we just have to put in a number for it to be able to do that math with, and then it would spit out a circumference for us. Does that answer your question?
Yeah, it makes sense for me.
Awesome. Any other questions about these, you guys? Okay, then let's head back here. All right, so looking at this, this is most frequently called a header in JavaScript. It's also frequently called a signature. So this is our function header or function signature. Again, like I said, we have our keyword function right here, which is required anytime you want to declare a function. If I look back at my code right here, you can see I declared just a variable circumference with the var keyword. And anytime I want to declare a function, I have to use the function keyword. Okay. We also have the function name, which is how we will call the function. Okay, so notice I have my get circumference header right here. And when I call get circumference, all I have to do is just say get circumference with my opening and closing parentheses. Notice up to this point in the class, we have called functions in every assignment in our buttons. Okay, notice I have the name template function and then opening, closing parentheses. And that is how I call this function in JavaScript inside the script tag that's named template function. And so right here on line 29, I'm doing that exact same thing, except I don't have an on click because I'm not inside of an HTML button. But instead I can just use the name of the function and the opening, closing parentheses. Okay, and then we have our parameters. And like I said, it could be one parameter like it was for the get circumference, or it could be multiple parameters. Okay. Any questions about this? All right, well, let's keep going then.
Does that mean that parameters in sequential order? So you do parameter 1, parameter 2, parameter n?
Yes, yep. So, and that's really important. That's a common mistake that's made. Let's say I had another function that was named get area, let's say of rectangle. Actually, that's a bad example. But anyway, let's say I had like multiple numbers in here, and then I had a function named get area, and instead of radius in here, let's say I had like length and height. Okay, for example. All right, these correspond. Okay, you need to pay attention where the commas are. Let me take this out because we're not using it. But you need to pay attention where the commas are in your parameter list and when you're calling a function. Okay, so right here, let's actually run this function real quick. And let's debug it. Okay, now none of this stuff on the page is going to do anything other than the run function. It's going to call this template function right here, which will call these other two functions. Okay, so I'm just going to put a breakpoint right here on line 30. And then I'm also going to put a breakpoint on line 26 inside of the area function, the get area function. Refresh that. Okay, so I'm going to run the function. I have a typo in here. Okay, JavaScript math.py is, oh, it doesn't have parameter, it doesn't have, it's just math.py. Sorry about that, you guys. All right, so I'm gonna refresh this. Okay, so in here, I have get area, with which if I hover over it, it just shows that it's a function. That's what this nice little funky f means. And then it has two parameters, and it shows right here, length and height are the parameters that it accepts. Okay, if I hit F10, it'll jump up here to my next breakpoint inside of get area. And if I hover over length, it shows 43, because that was in the first parameter that was passed. Okay, and if I hover over height, it'll show 50. That was in that second parameter. Okay, and if I let it go, we'll get an error because radius isn't defined. Okay, but that is extremely important, that our entire parameter list is sequential, and it is all comparative to whatever was passed in. And so if I put like null right here, or sorry, we'll leave that as length, but if I put null right here, like if I wanted to only pass something into height, I could do that, but I would have to have this like placeholder and a comma so that the program would know that I'm trying to put this into the variable height. Great question. Any other questions about this?
Can you name them? Can those be like your null and your 50? Are they considered a parameter, and your length and your height, or in the other ones like the radius, is that considered an argument?
Great question. Other way around. So when you pass in a value to a function, those are considered arguments, and then these are considered the parameters of this function.
Okay.
but they in the professional world they get used somewhat very similarly because they are very similar things. So, but yeah, great question. Any other questions? Okay, well then let's keep going. Okay. So now that we have the basics of function structure worked out, let's go into a couple of examples. Okay. So we just had our one example of, like the get radius or get circumference and get area. Here's one that computes and returns the average of three numbers. So you see this has three parameters, just a, b, and c. And inside the function, I add all those three values together and divide that sum by 3 and then return that value. Okay. And so here's an example of how we could, get the average for three numbers. Okay. Calling a function, again, just like I said, up until this point, we've been calling all of our functions with buttons in the HTML page. And so we just use the onClick attribute, and then you can type in a JavaScript command or a function call inside that onClick attribute. Okay, and now we'll see in this week that we're able to call functions from the JavaScript. So if you look at the bottom of this one right here, we got a couple of variables from the user. It looks like x, y, and a radius, and then we were able to call a function called drawCircle, passing in those three variables. Okay, so notice here in where we call drawCircle, I'm able to put in variables. I don't have to just type in like a 5 or an 88 or a string. I can pass in entire variables as well. And one thing that's kind of interesting about this, excuse me, if I look back here, notice that once I'm inside of this function get area or get circumference, I don't care at all what these were named beforehand. So right here, I just have plain values. They're not variable names or anything, but up here, they'll be assigned to this variable called radius or length or height. Okay, if I had a variable in here called r for radius, and it was 43, and then I pass in r right here, okay, it doesn't matter that this is called radius and this is called r. Okay, this can get kind of confusing sometimes. But if in here I try to say return r, that will give me an error because r isn't defined inside of this function. This function scope only knows what's inside of this function, including its parameter. Okay, and so as soon as I say that this is going to be named radius, I could put in anything I wanted right here. Whatever variable name, it doesn't matter. But this will not carry over to right here. This will it will receive the value of r, which is 43, and then it will be assigned to the name radius, which we can use inside of this function. Okay. Any question about this? Any questions about this?
Does that drawCircle command actually graph a circle?
Can we graph a circle? What was that?
The drawCircle, because there was a command that you had in the other code that said drawCircle.
Yeah.
Does that actually graph circles?
You can do stuff like that. You can draw circles. You can draw any type of shape. We won't go into any examples like that in this class. There's quite a bit of coding that's involved with that. But yes, so like this example right here, it has an x and a y and a radius. And so that x and y is to find the coordinates on the page for where you're going to start drawing your circle, and then the radius to compute the size of the circle so that it knows how big to draw the circle. But yes, that's what that function's for. Any other questions? Okay. All right, returns and assignments. Okay, in our first example with the get circumference, we had the return where we just returned the circumference value after doing the radius. Okay, this one we have function average. Here's my family, and it'll just get the average of these 5 numbers, divide it by 5, or the sum of those 5 numbers, divide it by 5, and then return that average. Okay, and then like we saw with the var circumference equals, we can call this function right here like this, and whatever is returned from it, we can assign that straight to a variable. Okay, so Birch family average height, we'll call the average function, compute the average, and then return that average and inject it into this var Birch family average height. Okay, any questions about this? This is a very common thing, very frequently used, having functions with returns with a specific value that will be assigned to another variable where we called that function. So any questions about this? Okay. So variable scope, we talked about this a little bit a second ago, but let's cover it a little bit more in depth here. So where to declare. If I want a local variable, I will declare it inside of a function. Now, all I mean by local is local to that function, okay? So right here, if I declared area inside of this function square area, it will only be accessible in this function. However, if I declared area outside of the function, it would be available to all functions, okay? So this example right here, I have total score, and let's say my wife and I, Sarah, let's say we were playing a game and we were trying to get like the sum of both of our scores over a bunch of games or whatever. Okay, anytime I called Nathan scores with a score, I would add that score to our total score. Now notice this variable total score is declared outside of these functions, and both of these functions are able to use it and append to it. Okay, and so this variable total score is an example of a global variable because it is accessible to all functions inside of our script. Whereas these variables right here, length right here inside of square area will be a completely different value than the length inside of rectangle area because they're separate functions. And same with the area. Variable area will be completely different than the var area down here because they're in different functions and they have their own scopes, their own local scopes to use. Okay.
So your previous example, was it the global variable then? Because it was outside of the function with the height of your family.
Yeah, so, whoops, I'll go back here. So with this one, Birch family average height, as soon as this is declared, notice it is outside of the function, which means this would be a global variable. Okay, depending on where this is called from. In this example, it's a global variable. If I go back here, the circumference would be a local variable to this function, even though it called these functions to get that circumference. Okay, but these would still be local, whereas this would be global because it's outside of the function. Great question, Lena. Any other questions up to this point? All right, well, let's keep going. All right, so you guys might be thinking like, what's the purpose of using functions? It'd be easier to just not use functions. But here are just a couple of reasons why we use functions, okay? You can control the flow and order of execution. So it is one of the control structures, changing just the default top to bottom execution of code. Okay, so you control when things are executed, how things are executed. Code reuse is a huge one. Okay, imagine if every single time I had to get the circumference of a circle, I had to rethink to myself, okay, what's that function again? How do I mathematically, how do I get the circumference of a circle? All right, and if I didn't want to have to ask Spencer every time, I could just write a function called get circumference, and then I could reuse that a billion times over. Okay, less code. It's less code because it's reusable. Okay, I won't have to rewrite the same chunk of code over and over and over again. With the averages, if I had a function to get the average of X number of numbers, I could reuse that as many times as I wanted. Fewer coding mistakes. Having multiple functions makes it easier to debug. You break up your code into smaller chunks that are more manageable, more modular, more reusable, and because of that, it's easier to isolate errors in your code. Okay. And you also break it up logically. So I can have a function for getting circumference, a function for getting average, instead of just like one function where I have to get, say a bunch of circumferences, doing all the math there, doing all the math for the averages, and have this massive function that does all of it. Instead, I can break it up. I can have a function for doing any piece of my calculations and then pulling that back and then continuing. Okay, easier to read and understand. When I say that, if and this is a bad example just because I just started writing this right here and this isn't an actual program that's very useful. But this template function could get pretty big if I was doing all the math right here. If I was doing all the math for these variables, if I was doing it all right here, it could get pretty big. Now, get area, get circumference, these are pretty simple formulas. But imagine if we had to get, say, an average of the circumference of 20 different circles. I could loop through, call get circumference 20 times for each one of my circles, and then have a function for get average and get the average of that and have inside of this function just like 3 lines of code. And so being able to split out different pieces of logic into different functions makes your code reusable, easier to manage, more logical, makes more sense, it's easier to read and understand, easier to debug, faster execution because of the other things that we said before. There's less code involved, and also variable name reuse. Now this variable name reuse isn't ever what I think about when I'm like, I should make a function so that I can reuse variable names. And when I say that, if we look at our example back here of area and length, that's what it's talking about here, where you can reuse variable names like area and length in different functions, and those will be restricted to that scope of the function. But that is one perk of having functions, is I could have a rectangle area and a square area, and I don't have to call them that. I can have these different things computed however I want to. So any questions about any one of these benefits of using functions? Okay. All right, so let's look at a couple of examples. These are straight from your book, from chapter 9, but I copied them in here just so that we could run them. So let's look at this first one. So this first one, example 14 from the book this week, is to get, it looks like we have a couple of different functions here. So we have a function to get the area of a triangle. We have a function called test pyramid, which is going to be called by the user. And then we have a function called pyramid surface area, which will take in values, in this case 8 and 7, and then it will end up calling triangle area to get the area of the triangle, and then get the surface area of our pyramid, assuming that our pyramid is an equilateral pyramid, meaning that all the triangles are the same size. Okay, so let's go ahead and run this, and let's see what it looks like while it's being run. All right, so all we have right here is a button, no inputs or anything. We have hard-coded right here 8 and 7 for the base and height of our pyramid. But I'm going to put a breakpoint inside of each function, okay, so we can see when they're being called and how they're working together. Okay, so I hit test. We have this on-click right here calling test pyramid, and so we jumped into test pyramid first. Okay, and on this line of code, we're going to have var PA, which is just for the pyramid area, and notice it's going to call pyramid surface area and pass in 2 values there. So if I hit F10, we're not going to go to line 16 like we're used to seeing it just like kind of going down when we hit F10 in the debugger, but instead it jumps down to pyramid surface area, and this right here is kind of on hold. Okay, and we'll assign the variable PA here in a sec whenever we return this value. All right, so we have our pyramid surface area function. If I hover over base, you can see I have the value of 8, which was passed in as our first argument. And for our height, we have 7, which was passed in as our second argument. Okay, and then in here, I can use base and height And you can see each one of them have their own values. I can use each one of them to get the edge of this triangle. Okay, so if I just hit F10, we have edge, which is 9. And then triangle area, here's another function call, and we're passing in 3 values. We have 8, 9, and 9, base, edge, and edge. Okay, so if I hit F10, you can see now we're on hold here to get our triangle area back. We're on hold here to get the surface area back. And now we're inside of this triangle area function, which we've passed in 8, 9, and 9 to. Okay, and I can use these to get our area, which ends up being roughly 32. If I hit F10 again, it jumps back to the call point where this was called. And now triangle area, or tri area, has that value of 32, which was returned right here. Okay. And now I can do more computations with tri area, which came back from this function, to get pyramid area, which is 128, roughly 129. And if I hit F10 again, it jumps back to this first call point where pyramid surface area was called. It assigned that value to var PA, and then it will output it to our output div in our HTML. Okay, so debugging, that is how this code runs. Well, debugging or not, that's how this code is going to run. Okay, each function where you call it will return whenever that's completed. So this function right here didn't return until this one was already done, and we weren't able to output anything on the page until this one returned. All right. Now I know that this was a lot, but any questions about this or anything you guys want to see again or didn't quite get with me running through it real quick?
I think I'm going to have to review the video afterwards when I can digest it a bit better.
Okay, yeah. I think that'll be really helpful for everyone. I did go through it kind of quickly. But the crux of this is just to recognize, that these functions will be called and we'll do everything inside those functions before it's able to assign anything. Okay, so if the value of this function call right here is whatever is returned in this statement, then I can't assign anything until this is fully computed. Okay, and it's the same thing when we call this function or any function. If we're going to assign it to a variable on the left side right here, then we have to be able to compute all of this first so that we can assign it to that variable. Okay, and that's why the debugger is really helpful, because it helps us see how things are running. If I just like put a breakpoint inside each one of my functions, hit F10 a bunch of times, be like, oh, I'm jumping all over the place here, and that's why. Because in order to compute the triangle area or the surface area of a triangle, or of a pyramid, we have to get each triangle area first and then multiply that, or the triangle area first and then multiply it by 4, return that, and then we can output it. Okay. All right. Any other comments about this? Okay, for our next example, let's go a little bit slower on this one. This one, I'm just going to copy the file path and stick it into our browser here. Let's look at it. So our defining table right here, we don't have any user input. The processing, determine the number of months required to grow an initial investment from $100 to at least $103 if it grows at an annual rate of 6%. Okay, so everything's hard-coded in here, meaning it's going to be exactly the same. No matter how many times I push this test button, it's going to be exactly the same because we don't have any user input. So these are hard-coded values. So we have an initial investment of $100, 6% interest rate, and this determined months, our third parameter right here, is our target parameter. Okay, so as soon as we push this button down here, test, we'll call our function, test invest, and then inside of test invest, we'll call another function called determine months. Okay, so let's think through this a little bit before I stick in some breakpoints and before we run it. What do you guys think will be the principal? When we get into this determine months function, what will the value of principal be?
100.
Yep, very good. How about annual rate?
0.06.
Yep, and so what'll target be?
103.
Perfect. Okay. And then in here, we just have some math, and then we have a nice little while loop here. All right. And it says, while balance is less than target, let's add some interest onto this thing. Okay, and see how long it'll take. Okay, and then we'll just increment months, and then we'll return however many months it took to do it. Okay, so again, just for us to see this debugging, I'm going to put a breakpoint on the first line of each function. So right after each function header, I'm going to put a breakpoint. Okay, and let's run this. Okay, so var m, what's var m going to be? Don't worry, I don't know either, you guys, because we're going to have to loop through this a bunch of times, but var m will get assigned whenever we're finished with this next function. Okay, so let's hit F10. Come into here, principal, I can see it's 100. Annual rate is 0.06. Target is 103. All right, so just going through this. This right here is very similar to an assignment that we would have seen in the last 2 weeks with our loops. This simple math right here is something we would have seen from like week 5 or 6. Okay, so we're just kind of building on all this. We have a monthly rate of 0.005, and our balance is currently 100. And then month, we just declare it at 0 to start off, and then we're going to loop through this. Okay, so again, we say, well, balance is less than target. We're going to add our monthly interest that we get, which is 50 cents. We'll add that to our balance. So we have $100.50, and then we'll increment month, which is currently at 0. So we've gone through 1 month, and our balance now is $100.5. Okay, if I keep looping through here, nothing surprising. You know, we're just going to keep on adding some compound interest. Our interest for this month is 51 cents. We'll add that to our balance. Now we're up to 3 months going. And so I'm just going to put a breakpoint right here on return month, and I'm going to hit F8. What F8 will do is instead of just stepping through each line of code, it will jump to wherever my next breakpoint is. Okay, if I don't have any more breakpoints, it'll just run the rest of the code. But in this case, I put a breakpoint right here to see what month will be. And it looks like we went through 6 months to hit $103. All right, I'm going to take that breakpoint off because I don't care about it. Hit F10, and it'll jump back up here. That number 6 that came back from this right here was assigned to M, and that's what we're going to output on the page. Okay. Any questions about this? All right. I would say probably the two most useful things that the debugger will come in handy for here. One right here, if I highlight from determined months to the end of the parenthesis, I can see immediately what it will output. I can see it came up to 6 right here. So just now when I highlighted it, the computer ran that function real quick with those parameters, and it ran it, and it's like, okay, this will be 6. Okay. The other really useful thing is when you come into a function, you can see exactly what is passed in these variables and these parameters. If I hover over these, I can see what they got. And then I can use them as variables in whatever I'm doing inside of my function. Okay. All right. Any questions about this or anything else you guys would like to see again? Okay. In that case, let's go back to our slideshow and look at some common mistakes here. Well, before we do that, let's have a quick note on return versus output. Okay, so notice each one of my functions had a fancy keyword called return. Okay, notice that return in and of itself didn't output that number 6 to the page. What outputted 6 to the page was this get element by ID output div in our HTML that we've used many times in the semester. Okay, the return only gave this a value to assign to a variable here. Okay, and if I wanted to, I could put this down here. You know, that would give us the exact same thing. But still, this returns a value, and this is what is outputting it to the page. Okay, so just because I say return here, I'm not returning it to the page. I'm not outputting it to the page. I'm just returning it to the call point of the function. Wherever we called the function, I'm going to return that value to that point, and then we can assign it to a value, to a variable. If I just called this function, which I can do, but I didn't do anything with the return, this function would not look like it did anything here, okay, because I don't assign anything to its return value. Okay, now I could rewrite this function a little bit and take this right here, and instead of saying return, I could say, okay, once you get the month, output that to the page. Okay, and then I could just call this function, and that'd be just fine, because I'm not trying to get a return value from it. Instead, I'm just like, okay, call the function, determine months, and then output that to the page. And then in that case, we did that. Okay, but the act of outputting and returning are very different things. Okay. Any question about return versus output? Okay. Now let's look at some common mistakes. All right. So putting a space in a function's name. Okay, you guys might have figured this out earlier in the semester that you cannot put a space in the name of a function, but this is invalid code. If I tried to run something like that, like let's say I put a space right here, notice that these colors are funky. Okay, that's never a good sign, but let's try running this and see what happens. Okay, if I refresh the page, notice I get a nice little red error here, unexpected identifier. It's because I said function test, and it's waiting to see a parenthesis right here, and I didn't put one. Okay, so as soon as that string ends, in this case it's test, it's going to be like, okay, where are the parentheses for this function that you just declared? So yeah, no spaces in functions. Next one, forgetting the opening and closing curly brace. Okay, this is a big one because if I have a function right here without a curly brace, you're going to get an error in your console, and your code's not going to run. And the reason why JavaScript requires you to have curly braces is so that it knows what to do in your function. All right, so let's do that. If I take off, let's fix that. If I took this off right here and ran it, let's see what we get. Okay, another error. This one's not quite as clear. Okay, if I look at this, it just says unexpected end of input. Okay, I've seen this a lot this semester, people who forget closing curly braces. It's not something new to this chapter or just now that we're learning more about functions. But anytime you see this error, unexpected syntax error, unexpected end of input, it's because you missed a closing something, whether it's a curly brace, a bracket for an array, a parenthesis. It could be any one of those things to get this exact error. But if I look at this, it jumped to the very end here because it didn't expect me to close my script tag. It's like, hey, we're still working here. And that's because if I look at this right now, technically speaking, all of this now is inside of this function because I never closed this function. I never had a curly brace. This function will stay open as long as until it finds a closing curly brace, okay? Which in this case would be this one because they're all nested. So these curly braces will line up and this curly brace, so this function will stay open until it has a closing brace. And in this case, it's like, hey, unexpected end of input, we needed a curly brace, So yeah, don't forget to use an opening and closing curly brace. One thing that's nice about Sublime, and I'm sure Visual Studio Code does this too, but if I say function get some value, as soon as I type in my first closing or my first curly brace, it'll type in that second one for me, and I can just hit enter and start typing for my function. So, all right, any question about this common error? Okay. The next one is redeclaring or reassigning parameters. Okay, remember when we were talking about like the area and length, how the square area and the circle area were completely different areas? So in here, I have a get discount rate, let's say, you know, for like a senior citizen or something, you could get a discount at a restaurant or something. So we'd have to like pass in the birthday. In this case, we're passing in GPA, so ignore my senior citizen thing. But anyways, you don't want to reassign variables that came in as parameters. Okay, a parameter is an important thing that the user oftentimes typed in, or that you are using to, you know, get some type of mathematical value from some computation that you're working on. So you never want to reassign those values. If I reassign this birthday as new date, 3/17/1995, it doesn't matter if that's the birthday of the user. If I do this, I have completely destroyed the purpose of having a function right here for get discount rate. Okay, I have a return rate right here, which means if I build this function properly, I'll be able to reuse it as many times as I want for as many people as I want. If I hard code a birthday in here, you know, like, it will completely negate the purpose of this function. So you never want to redeclare parameter values. Okay, these are declared. You don't have to redeclare them. You can use them. So yeah, the correct way to do this example was, you know, just you use your birthday. It's right here as a parameter. Use it. Same thing with GPA. You know, you can use it. So, any questions about this one? All right. Any questions about functions in general or anything else that you may have seen today, or any other questions you may have about the class? All right. Well, you guys, thanks for sticking it out with me. If you guys end up having any questions while you're reviewing this recording or anything, just let me know. But yeah, thank you guys for coming, and good luck this week.
Thank you. Thanks.
Thank you. Talk to you guys soon.